Everybody, continuing along, we've got a assumption here of a message queue between my C++ and a Python script that I just developed with charting and maintaining a MongoDB. So let me just show you all the tools we got running to make this script happen. We've got a product here called Toad, which is a database client to view Mongo databases. Now, what all this stuff that I'm showing you with a database and a lot of the code comes from my Python interactive building blocks course. So, sorry, let me say that again. My infrastructure building blocks course, which I did about maybe a year ago. So all that code I'm going to show you is from that course, as well as this particular database as well, which is in Mongo, not Redis, Mongo. And the difference between Redis and Mongo is Redis is an in-memory database, and that's purely what it's great for things like queues. That's perfect. When it comes to more of a document type of store, like a relationship database, sort of, you would use MongoDB, which is another type of NoSQL database. On top of that, what we've got here is we've got actually two databases running. We've got Redis here on the left, and then we got Mongo on the right running, because we need both running in the background to work both the C++ and the Python script. So on top of that, I'm using the Python IDE, PyCharm IDE for the Python part. And then, of course, I'm using the Xcode for the C++. So what we're doing here in this particular situation is, if we rewind back to my channel and you look at all the more recent videos I've just put up before this one goes up, you notice here we've got an intraday charting for algo trading with Python source code. So that video goes through the detail of all the charts that I'm showing you. This one is a source code walkthrough of a Python C++ message queue with, I believe it's subpub, the pattern publisher subscriber. This one's another one you may want to watch, is this demo simple C++ Python message queue with Redis. Okay, so these are three critical videos you may want to watch. All right, so let me describe what we're doing. So this video here will describe how to build a message queue between a C++ and a Python using Redis as a queuing. Okay, I've got enough videos and whatnot on Redis in the playlist, so you can always check out that. This video, source code walkthrough of Python C++ message queue, where what we're doing is we're sending in data from a Python script that will be watching data that's being sent into Redis from the markets. Usually the data source will probably, let's say, IQFeed. So once that market data is pushed into Redis, there is a script that will then turn around and push and do some calculations. Like I've shown demos of all the major calculations or algorithms using beta, alpha, momentum, some stats, and so on. ATR, average true range, which is a critical one. And eventually I'm going to do a co-integration one as well. So it's going to be like 6 algorithms or calculations running that get pushed into now Redis for market data. But it's not just the market data, the pricing for the pricing action, it's actual calculations of that data from past data from a rolling window of some kind that's pushed into Redis. So with this script that I'm speaking of in Python, that is assuming we want to put on a pair trade. Okay, so we've already put on a pair trade entry. So the next step is within the C++, which I show, are the various calculations you can also run. That's a subscriber that's going to read in that data from Redis and do further calculations to gauge for a market exit, okay, to take the position off. So that's what this video here will go through. It's pretty lengthy. On top of that, I've had to do another step to showcase the charts in great detail. Okay, so I'll show that in this script, but I won't go into detail how they work because that's already covered off in this video here. Okay, so enough blabbing. What I've got in my Python here is I got a script, of all things, called exit. So what this script will do, it will do a number of things. It will put the position data when the entry, or sorry, when the exit takes place to take the position off. It's going to track and insert a row into my Mongo, all kinds of stuff like the exit, short, the long, short. Now remember, this is a pair with a long and a short. So it's going to need all that data. On top of that, part of my calculations will keep track of the upper band and lower band of a soft target as well as a stop loss. And on top of that, we will also insert the short beta and the long beta at that current time of the exit. And obviously there's a timestamp, as well as there is the same data for the soft target, stop loss for both the short and the long. So that's what we've got here. And of course, we'll track the exit price as well. Okay, so that's what we're going to insert into the database. So that's one step. So that will get thrown into the database. Again, all this code is in my infrastructure building block course. So obviously the function is going to be called insert Mongo. On top of that, if you look carefully, there is a charting function here that's called as well from within the insert right here. So what this does, I did call this, this is the old insert TA, technical analysis script that I had in this previous video here, but I just renamed it to insert chart. Simple stuff, right? It's the same function, just it's just merged into one function. Does the same, but on top of that, I am passing in a few other items. So what I'm passing in is the upper soft target for the short, as well, lower soft target, upper stop loss, and lower stop loss for the short. And I'm sending the exact same set of data in for the long as well. Okay, so I'll show you that in a little bit on those lines that get charted. Okay, so those are the two big functions that this, or purposes of this insert Mongo, is to insert the row of all that data into Mongo on top of the actual two charts that get created for both the long and the short. That's all this does. So that's all this little guy does, and it's just set up listening to as a subscriber now in Redis, and it's listening to Redis for any messages coming in. And basically what's being sent is on the C++ side. So if you look at the C++ here, this is the old, from this video here, this one here, the long one, source code walkthrough of C++ Python message queue. So I've added some new code to it. So this Redis pub is essentially, these are both gonna run at the same time, but this is just the only thing running, only function that's gonna run in this test. All we're really doing is using Redux again for Redis, the C++ wrapper for High Redis, is we set up a publisher, which this code really isn't needed. The subscriber, it's not used. Connects into Redis and pushes this data, the row, Apple, IBM, along with the data I just showed you. I'll go through in greater detail. Pushes the data in with a topic called order. Okay. So at the other end, what we've got here is we've got listening to order, and what it subscribes to is the order topic. Pretty simple. Okay, so let me just set this up and let it run. So right now it's listening to the queue from Redis called, and it's looking for anything that subscribe, or it will subscribe to order. So what the C++ does, again, it's going to publish the order with this information, with this data. So if I run it, when I run it, yeah, so it's set up to run. So I will go ahead and run this. Got an error somewhere. Let me correct that. Oh no, wrong project. Okay, so we want this one. Okay, so obviously it goes orders, push, and then it just ends. That's all this C++ program does. So what the other end does, it listens to the order, captures it, and I'll show you this. This is where it splits up the message, and then it will also generate 2 PNG charts. So let me show you those. So here's the Apple one. Now, again, nothing's changed in that chart. The only thing that's really changed here are these 4 lines. This is the upper soft target. This is the upper stop loss. This green dashed is the lower stop loss. And this one right here in red would be the lower soft target. So essentially what we're trying to do here, and this is obviously dummy data, just for demonstration visual purposes to test it, is once we get the pricing action, the system will be able to, like if I set my soft target and my soft target as well as my stop loss, the system in the C++ side will be adapted to be able to automatically rule these targets and stop losses automatically depending upon what's happening in the market data, live data. On top of that, I can also, with other algorithms that I've mentioned here in this video, be it stats, be it whatever, statistical or beta or co-integration calculations, I can run also in parallel and have them also measure the exit. So that's what we're essentially doing in this chart. And once something gets breached, an exit condition matches, then what we do is we'll send out the order of the exit, and that's what this typifies. This is what it's to simulate. So at the other end, what we have here through the Redis queue is we have this new exit script where it will raise that trigger, or trigger the event of the order, and then, as I said, put in the order and put it into the database. I'm actually going to log it as well and create a chart. But right now, the 2 big things that I'm doing are the chart as well as putting it into the database. So the 2 outstanding things still in this set of programs is logging of the data of the position of the exit, but it's already kind of technically logged in Mongo. I'll show you that in a second. And we also have a visual representation created as well for both the long and the short, as I shown earlier. So let me show you the database. As I said, this database is fairly detailed in my infrastructure building blocks course. And I'm using the exact same thing, same code. And what we're marking off here is the long beta, the target that we set. Now that target could be set before we put on the position. Okay, there's a number of calculations we could do using standard deviation as an example, and we're also using ATR as part of that calculation. So we also have a band, as I said, of a down target for the soft target, and the current entry price. So here we're measuring the long beta at the time of the entry, the down target, as well as the entry price itself. So that would usually get marked off when the entry takes place. But right now we're just updating the database when we do an exit. That's what we're focusing on here in this video. So we have a long entry, we have a long exit price. So here we set it at a dummy of 167.32, and then I just put in an arbitrary low stop, but this would automatically be calculated from the C++ side. Again, quantity right here is odd. This won't be looked at for quite a while because I'm doing micro trading. This really is one of the very last things that will be measured in terms of number quantity of shares that I'll buy. So I'm just going to assume 1. The system, when I automate it, will be just 1 when I start out my initial trading. But the funny thing is, when you start worrying about position sizing and the quantity, number of shares you're going to buy, that goes into another world that I haven't yet. I mean, I have the idea how to do it, but to actually position size and how many shares I'm going to buy would go against market conditions, risk, how much risk I'm willing to put on from within my current portfolio. On top of that, we also have to calculate how my performance is doing. So I'll be using something like a Kelly criterion to measure my current performance in terms of how the system's trading. So I'll be able to help throttle and protect the account from getting blown out. So we also have here the soft target, as I showed you, a percentage. Now this is the percentage on the difference between the entry and the exit. This is key because usually a lot of human traders will say, okay, I'm going to put on a position, I'm going to put my percentage of my stop loss at 5%, right? That's fine, or 10%. So once you hit that stop loss, get out of the market. That's fine, but here I can dynamically set that. And if we breach that within the C++ program, we can automatically exit no matter what else is going on in the market, or regardless of what other calculations are telling us. We could set that percentage. Once we break through, get out. But on the other hand, we don't want to have the stop loss kick us out of a potential profitable trade if we have a running position on the profitable side or on the upside. We want to prevent that from happening. So we have to dynamically ensure we have that logic developed within the C++ side. And we have a symbol. We have our range of our stop loss. And of course, we measure the beta. It's kind of important because from a P&L perspective, we can look at that point and measure the beta of how that particular position or this particular trade did against the S&P 500 at that time, which is kind of important for P&L at some point when you do closer analysis, especially when you're trying to tweak these kind of strategies. So of course, when we move into the short, we have the entry price, short entry, timestamp, exit price of the market. We have our low on the stop, and a quantity again that we talked about for the short, stop loss percentage. Again, we've talked about in our upper stop. Okay, so that's what's in the database. We track that, and that gets logged in the database. Okay, so if you want, I can go through the code. I've gone through the C++ side. This is now in greater detail. So let me go over to the Python here. Okay, so there's a lot, it doesn't sound like a lot, and really there isn't, but unless you know in great detail what I'm doing, you'll have a better idea. Okay, so let's go through this. This is the main part of the program, of the script. So again, remember we've got two databases running. We've got Redis on the left and MongoDB on the right. And again, all that detail is set up and described in my infrastructure building block course. Cool. So let's go through this. So as I said, this is the main part of the Mongo, as well as we got two functions in here, which is really just the insert Mongo and this exit Python script. So going into the main, we just set up a configure. As I said, the code's the same, just moved it around. That's all I did. So what we do is we we set up our connection into Redis. I'm getting confused between Mongo and Redis. And this is to establish, to connect into the queue that this program on the C++ is publishing to. So again, let me just go through that, probably help you out. So as previously described here in this video, what we've got is very carefully this new function called Redis_pub. This is C++ and Xcode. So we do our usual connection into Redis with all the default ports. We set up we fudge basically our data, our Apple, which is the short, long, IBM with the associated data we've gone through. Yeah, we say order pushed as down here. Now remember, we're publishing on the queue on Redis using the topic called order. And then we send with it this message, the row, and disconnect. Pretty simple. So again, on the receiving side, on the Python, what we've got here now is in the main, we've got our connection data, localhost, default port, real secure, I know. And we set up the connection. But here, no different, no surprises here. This should not surprise anybody. But we set up our pub sub pattern, publisher, subscriber, and now we subscribe to our topic called order. Let me show you again. The C++, publishing to order, the topic order, right here. And then again, on the subscriber, because we're subscribing to it on the Python side, we're now subscribing to order. Cool. So what we do here is basically we're now going to listen to that queue on the queue of the topic called order. So we get some data because we're listening. The event gets raised. We can now extract our data because of the message, which is really this right here. Because we send that as the row, and that gets picked up or received on the Python side. Now, this is important here. We need to test, for some reason, this Redis package in Python. We need to test that we're actually receiving a string data type. So that's what we're doing here. If not, continue in the loop. Otherwise, we have a string, so split it up by parsing it by comma, put them into tokens, right here. And all we're really going to do is just pass those tokens to that insert Mongo function. Pretty simple stuff. So here's our insert Mongo. So this is all the cool part about it. Here we parse up our tokens are already parsed up and split up. So we just split them up into the associated data points that we need. For instance, soft target on the short, the lower soft target for the short, lower stop loss of the short, upper stop short, on and on it goes. But here we're also tracking our timestamp We're also tracking our beta for both the long and the short, as well as the exit prices right here. Okay, pretty simple stuff. Now, as I said, we've already covered for the charting this video right here. So now we know that. So here's our charting stuff. So we pass in the symbol short, and obviously we're going to pass in the lower, upper soft target data, lower soft short target, and these are pricing, upper stop loss short and lower stop loss short. Okay. Now that's for the short. So we're going to chart also at the same time the long with the same data. So let me go back to the chart. So again, these lines right here represent these four: upper soft target, upper stop loss, lower stop loss, and then the lower soft target. Okay, that's what that means. Before I forget, as an example, if I get rid of this, let's say we have a downward motion on Apple, or let me see the IBM one. This is actually a better example. You can see here we've got some pricing action. Now this is again starting today, 10 o'clock or however it was, whenever this data is from in the last few days. Pricing action goes down. We have a moving average and a 50 average. Now, again, just as one example, which is very simple, if the price breaks one of the moving averages, we could have an exit and an entry. We could use that as one example. Okay, but we're using a combination. Or here, if we know, like this is a perfect example where we have pricing action right here, it broke through our stop loss. Maybe we should have exited the trade. And if we did, we made a tiny little bit of money, 0.4 cents. Yay. But it continued down. So, that's one way to exit. Now, let's say if this price continued to go up, okay, then we know we could have had the stop loss kick us out, or the soft target kick us out. But who knows? The momentum may have been not in our favor. Maybe not. But this is part of the automation and the algorithms to know when to get in or out. But it's a whole combination of things. But you can see here in the RSI, it kind of looks like, well, it did get overbought. And it went down. So when you look at these patterns here, now it's overbought. So you can use the RSI as another pivot as well as a MACD if you want. Okay, this is again on an intraday chart. So there's all these combinations of algorithms that we need to focus on the exit. Okay, so it's kind of important to understand that, but there's gonna be a lot of tweaking to really get a handle on that. But you can do it, as you can see here, in a really automated way. All right, so back to the code. We've got these charts here of all the upper soft loss, soft target. The other thing about these charts, let me pull up the IBM one, is for risk management later on, because we have now the flexibility of tracking our stop loss and our target with a combination of all the other stats that we've talked about, the metrics, we could just say, okay, I want to put on a position, but based upon our portfolio and the risk and the performance of the portfolio, or performance of the current trading, maybe let's say I'm in a losing position the Kelly criterions tell me, oh no, you're doing bad as a trader. We're only going to put you on a half position, but yet on the same time we can automate the system to say no, but we have other metrics that are saying we have an upward momentum. Do some probability, and then we can add on from a half position to a full position based upon that risk. And how we do that is measured through our number of shares through the quantity. So we have a lot of flexibility here based upon our risk performance, what the market's telling us, and at the same time we can automate it in a way where we can protect our account. Lots of flexibility here. It's pretty cool, I think. Once we can get all the right combinations down, we're sitting pretty. Okay, back to the code. So we do all our charting. Cool. So as I said here, we're now going to go and do our Mongo database stuff. Now again, what I'm about to show you is again in my infrastructure building block course, because we have a section on Mongo and databases like Redis and Mongo. So all that data gets put in. Actually, it connects into Mongo here. Now, instead of calling it topics in the Mongo world, we call it a collection. So we set up our collection, which is called, oddly enough, positions. And we have two things we're going to look for first. Because remember, this is critical. Right now we're focusing on the exit. But some time ago, we've already done an entry, right? This is an exit. This function, this Python's called exit. So we know we've already done an entry at some point. So this row, this record should already exist because we've done the entry. Now, if it does exist, which is this logic here to test that condition, so if the position counts equals 0 for whatever, it shouldn't happen, start inserting some data. Well, you're screwed because there should be a row count of 1. 1 for the combination of the short and long. If so, insert all that data I just showed you. As well, this is in development. There's more stuff I'll be adding to the row or to the Mongo database a record, I guess you'd call it. What I'm referring to are these guys right here. Okay, that's what we're talking about. Okay, and that's it. That's the whole script. Pretty simple. Just for the exit, this is what we're going to do. But of course, we're going to build upon this. But for now, the next step is to actually go back into C++, finish off the logic here. If you watch this video here, this will explain quite literally what I'm talking about right now on the C++ side. So what we need to finish off here is the lambda for when we get our message. So this right here, this is where all our logic will go in for running our set of calculations, metrics, algorithms, or whatever to test the exit, to take off the position. So we got to build out that logic. And remember, I said two things in the Python side in this little program, in this exit Python script. Two more functions need to exist. The logging of the position, because we want to replicate our record keeping for both a database and an actual log file. On top of, we got to worry about the actual order, sending it back to interactive brokers. And I'm going to be honest with you, I'm not going to show you that because guess what? That is in my Interactive Brokers API workshop that I did late last year. And that's going to be done obviously in C++. And the other thing is, on the C++ side, that will not communicate with the TWS. That's actually going to be communicating through the gateway from Interactive Brokers. And the reason I'm doing that is I'm trying to leverage as much C++ as possible because, as I said in previous videos, your concurrency, multi-threading, all that is critical. So that's where I'm focusing a lot of this exit logic in the C++. The Python is only really used for the simpler stuff, creating a chart, logging, and what else? All the database stuff. Because doing that in C++ is hell. Let's leave it at that. And it's better, the less the C++ side does, the better. Because then when it comes down to wanting to like take this code and move it into potentially a sub-second type of environment, that transition should be a lot easier. So that's why I'm doing it the way I'm doing it. And especially on, if you watch, I mean, hopefully you watch this video here on the walkthrough of the C++ and Python message queue, where you'll see I'm actually doing all the heavy calculating before I put on the position and call the C++, and I put in all the results of those calculations into the database, and then just send that calculated data into Redis, and then having the C++ side just basically run it through like a filter. So that will make the C++ side much quicker because it's got less to do. So that's how I'm architecting, why I'm architecting it that way. All right, so everything's kind of come together, sort of, but I still got those two functions, the logging, which is fairly easy, as well as the actual order. So hopefully I'll be able to run a demo and just basically build out an actual schematic of the architecture of this, because you're probably having to watch this a couple hundred times to fully understand what I'm doing. So hopefully I'll have a visualization of the flow of this with the mechanics of the databases and the programs and the scripts running to make all this happen. All right, so we'll leave it at that. Thanks for watching, and let me know what you think. Talk to you later.